On today's webinar, we will demonstrate how we can perform credit scoring for loan applicants using machine learning. I would like to welcome our guest speaker, Jan Kuchera from CGI. In this case, the global banking institution required to determine whether a loan will default, as well as the loss incurred if it does default. Unlike traditional finance-based approaches to this problem, where one distinguishes between good or bad counterparties in a binary way, we seek to anticipate and incorporate both the default and the severity of the losses that result. In doing so, we are building a bridge between traditional banking, where we are looking at reducing the consumption of economic capital, to an asset management perspective, where we optimize on the risk to the financial investor. I would like to welcome our guest speaker, Jan Kuchera from CGI. CGI is the 5th biggest software and service provider in the world. The algorithm that is used for credit scoring was developed by CGI and BellaDati Analytics IoT framework, and its studio was used as end-to-end solution.
Hello, my name is Jan Kuchera. I'm data scientist at CGI, and I would like to tell you something about loan default prediction. Loan default prediction is, standard task and problem which banks and other financial institutions deal with every day, and it's really interesting for them to really take this problem and solve it as best as they can, because it generates them a lot of money. The task is, the tools that are used for this task is very often some scores and credit scores. Here I would like to show the standard Fitzer score, which is, I guess, benchmark of the scores. As I said, I would like to specify the problem at hand, which is really to predict whether a loan will default, and which means if I, as a bank, borrow money to a client, if he's able to repay this debt to me. This is a standard task, and the enrichment of this task is to ask how much. If the client cannot repay the debt, how much will I lose? How much he cannot repay? The standard task I show in the picture on the left. This is a cumulative Fitzer score distribution in the population. This means that I would say people, the amount of the people on the left. They are the more riskier clients with low Fitzer scores. On the right, they are the representatives of the safer clients. This graph doesn't mean that there are much more safer clients than riskier clients, because it's a cumulative distribution. Therefore, on the left, there is 0. And on the right there is the whole population. The red dashed line around 700 shows a threshold which the bank defines, and by which it says clients on the left from this line, we really say that they are more riskier. To the right of the line, they are safer for us to borrow them money, lend them money. On the right, the figure on the right with the two plots shows the enrichment of this problem. In the top part, we can see the same cumulative score distribution, and below that there is plotted the average value of the loan. We can see some general progress that there is the loan on the left has generally smaller value than the loan on the right, This means that the more riskier clients for the bank tend to borrow less money than the ones on the right. But as we can see, for example, around the amount of 450 score, there are loans that tends to be much higher than in their immediate vicinity. This means that even though that these clients are more safe than, for example, at the score of 420, if they don't repay, then the amount that they won't repay is much higher, and even we can see that with the credit score of 500, there are more safe clients, and the amount of the debt that they won't repay is much lower than the amount of these clients. Which means that for the bank to know how much the debt is and how much what part of the debt the debtor cannot repay is really interesting. The algorithm or the model we used for prediction is gradient boosted decision trees. This is a really popular algorithm and tool in the machine learning community because it generalizes well, it has good predictive capabilities, and it's really popular even on the business side of the spectra because it is very well human readable. On the right, I have examples of some trees, some decision trees. We can see that if we want to say if client of the bank will repay or if the loan to him will default, we are measuring some attributes of his, for example, his income, and here the tree tells us that if his income is less than 30k and his age is less than 25, then probably the loan will default. On the other hand, if he's older than 25, he will probably repay the debt, and so on. So this is nice for the business people because they can see almost right away what are the attributes that are interesting to the model, which have so-called high predictive capability. The take on this problem from this site was to firstly classify the clients into two groups, whether they will repay the debt or they will default. And for this, we trained a classification tree, which really did only this. After that, we used so-called ensemble learning, and we also trained another gradient boosted decision tree. But the outcome of this tree was only the loss incurred on the bank if there is a default. This is characterized by the second tree, and for example here we can see if the first attribute to look at would be employment, if the client is employee and the time since his last job change is less than a year, then the loss the amount that he won't be able to repay will be 62% of the debt. If he's in his job longer than 1 year, then the loss would be around 37%, and so on. So first we train a classifier which says whether the loan will default or not, and then we train a regression tree which says what will the loss be when the loan will default. And this is really the interesting part of this solution to the task at hand, which was loan default prediction. This is all from me. I thank you for the attention. Goodbye.
Thank you very much, Jan Kuchera, CGI data scientist. And now we will have a look at how data of an applicant are collected. The bank uses standardized forms. The applicant can fill in the application online or in the paper form using, for example, this form. BellaDati Analytics IoT Framework can create any customized form that is used for online data submission. The data about each applicant are recorded in BellaDati database. The applicant can submit the application in the paper form. The application form is scanned, and data about that applicant are transferred to BellaDati database. We have uploaded trained data in standard way in BellaDati. The file for each applicant contained 120 parameters, such as the applicant ID, size of loan, maturity of loan, demographical information, loan complexity classification, and so on. Then we used BellaDati Machine Learning Studio to create the model, to test the model, and then we have used the model to predict probability of losses for each applicant as the output. Based on calculated probability of losses, the bank can predict and manage the credit risk of loan portfolio. The bank as well as a leasing company can use such credit scoring prediction to provide or reject the loan. In section Variables, we can see that we have available 4 datasets: mapping, predicted data, trained data, and test data, which we will further use. Using BellaDati Framework Packaging and Import function, we import Credit Score Algorithm package to BellaDati ML Studio. With packaging and importing function, we can easily transfer created packages between independent instances or domains. The algorithm was written by CGI in Python with the usage of Anaconda Python libraries. Such functionality is available in BellaDati Machine Learning Studio. Then we click on Run the project. As the first step, we select Use GUI interface and define how we want to map results of prediction. In our case, ID will be in the first column and the loss probability in the second column. Then we select in which dataset we will record predicted data and from which dataset we will read trained data and test data to train and test the model. After the selection, we run the calculation and get out for predicted probability of losses in the second column in percentage for each ID, i.e. for each loan. If the probability at the second column is 0, there are no losses expected. We further immediately use prediction for losses for further visualization, analysis, and modeling. Based on the model, we get prediction of losses for each application. The bank categorizes the loan according to the duration, 3, 4, 5 years, the size of loan, 50 to 100,000, 100 to 150,000, 150 to 200,000, and 200 to 250,000, and risk category in regards to the loss probability, 0, 1 through 4, 4 through 8, 8 through 12. We can use filters on the side and filter loans by category. Pareto analysis of volume of loans in each maturity category, 3, 4, 5 years, and related number of loans with some probability of failure and probable losses immediately indicates that loans with maturity of 3 years that represent 16% are of higher risk to be unpaid than the loans with the maturity of 4 years. Bar charts indicate the relative level of risk for each loan category. Loans with maturity of 3 years have the risk percentage not to be paid of 1.25%. Loan in the size category 50 to 100,000 have the highest risk not to be paid of 1.35%. Line charts at the bottom further indicate that the financial institution has the highest amount of the capital in loans with maturity of 5 years and in the size category 200 to 250,000. These loans belong to mid-risk category with a risk level not to be paid of 1%. For more comprehensive analysis and visualization, we use 3D charts that show correlations between loan maturity, size of loan, and loss from unpaid loans. 3D charts can be rotated and zoomed to get more detailed insight. BellaDati framework can be further used for ready-made what-if scenarios. We can model what is the percentage of loss versus interest income if interest rate is changed or if risk level of accepted loans is increased or decreased. Thank you very much to our guest from CGI, and thank you for attending our webinar.